Hello students, in this lesson you will learn about the 19 volt section and the charging section. In laptop motherboard, there are two types of voltages produced. One is primary voltages and the other one is secondary voltages. Before power on, three voltages are produced. That is, if the charger is plugged in or the battery has enough voltage. 19 volt, 3.3 volt and 5 volt present at these stages. These voltages are called primary voltages and always on voltages. After powering on, the remaining voltages are generated sequentially. These voltages are called secondary voltages. Let's see how the 19 volt DC backed out voltage is produced. When we connect the charging adapter, which has 19 volt and 3.5 ampere current, the 19 volt is fed to the charging IC via a resistor which drops the 19 volt to 2.5 volt. This is called AC in supply to the charging IC to determine that the charging adapter is plugged in. If the charging IC senses that the adapter is plugged in, it supplies the gate signals to the two P-channel MOSFETs. After getting the gate signals, the two P-channel MOSFETs passes the voltages and we will get the 19 volt across this resistor. This is the first voltage generated in the power on sequence. If the AC in of the charging IC drops below or above 2.5 volt, it will not send the gate signals, thus blocking the adapter voltage to pass through these two P-channel MOSFETs. If the adapter is removed, AC in drops to 0 volt, so the charging IC stops sending the gate voltage, thus blocking the voltage to come here. In the meantime, if the battery has enough charge, the charging IC activates the discharging MOSFETs by setting gate signals and 12 volt present across this resistor. Now the laptop is in discharging mode. On the other hand, the laptop now working in the battery mode. In the charging mode, these two MOSFETs will active and the discharging MOSFETs will be in off mode. If the charging plug, the adapter is unplugged, these two MOSFETs will deactivate or will not work and this discharging MOSFET will active and the battery voltage 12 volt will present across this resistor. The charging IC also gets enough information and the signals from the super IO IC to charge the battery. The charging IC also generates the charging voltages via these voltage regulators and send the charging voltage to the battery to charge at this condition.